Good morning, students. This is Mr. Boyd. Welcome back to another lesson in algebra. And today we're going to take a look at a lesson on solving absolute value equations. So we know that an absolute value is the distance a number is from zero. And distance is always positive or non-negative. Now, when I say non-negative, that means that distance could be zero, but it cannot be a negative answer. Solving absolute value equations is almost exactly the same as solving regular equations, except in most cases you have two solutions. So let's take a look at some examples from previous years, prior to Algebra 1. So the absolute value of 3 is 3 spaces, or 3 units, because 3 is 3 units from 0. Likewise, the absolute value of -3 is also 3, because -3 is also 3 units from 0. We draw a number line. We take a look at 0, and where is 3? Where is -3? Well, they're both 3 spaces away from 0. Notice the answer is positive on both of these. Likewise, if we take the absolute value of 7, it's 7 units from 0, and -7 is also 7 units from 0. So now let's flip the script, so to speak. What numbers are 5 units from 0? Well, that would make x equal to 5, or the opposite of x equal to 5. Now to solve this, remember there's a -1 in front of the x, so we would divide by -1, and x equals -5. So the two solutions here would be 5 or -5. Likewise, x equals 75. The absolute value of x equals 75. So x could be 75, or the opposite of x would be 75. Again, we'll divide by -1 here, and so x could also be -75. Now, the absolute value of t equals 0, well, we don't have two solutions here. T can only equal 0. If we put down the opposite of t equals 0 and divide by -1, we still get t equals 0. So the solution set for this last one is just 0. Let's go back and write the solution set for this second one. Could be -75 or 75. Notice I'm using my set notation again. So how do you solve absolute value equations? Number one, you want to isolate the absolute value expression. If there's multiplication on the outside of the absolute value bars, do not distribute, divide. Split into two separate equations, as we did above. One with a positive algebraic expression, the second with a negative. Solve each equation. Check by substituting the solutions into the original equation and see if it makes it true. Remember, solutions make an equation true. All right, so let's take a look at our first worked example. So, we don't have anything outside of the absolute value bars to isolate. So we'll go ahead and start with the inside the bars. Okay, so the first equation is going to be 3x equals 45, or the opposite of 3x equals 45. And then we want to solve each one of these equations. So to solve the first one, we'll go ahead and divide by 3. That'll give us x equals 15, or Let's take a look at the second one. Okay, I see I've got a negative out here. So that would, I need to divide by -1. That's going to give me 3x equals -45. So then I'll divide by 3 here also, which is going to leave me with x equals -15. Now don't be lured into the trap of thinking that the solution is going to be always be a number and its opposite. Now if we're asked to graph these, and we most certainly will be asked to graph these at times, remember that a shaded in dot shows that something is equal. So we would place a dot on 15, and we'd place a dot on -15. Okay? All right, let's go on to the next worked example. So here again, I see that I don't have anything outside of the absolute values, bars. So the absolute value expression is already isolated. So I'll go ahead and write my two equations with or between them. So the first one, always 2x plus 6 equals 16, or the opposite of 2x plus 6 equals 16. Okay? So let's go ahead and solve this first one. Let's see, I think I need to subtract 6 first, because that's the inverse of adding 6. That leaves me with 2x equals 10. Next, to isolate x, I'll divide by 2. And that's going to give me x equals 5. All right, in the second equation, I notice that there's a negative outside the parentheses, which is a -1. Now, I could choose to distribute, but I think a simpler way to tackle this one to begin with is to go ahead and just divide by -1, which is the inverse of multiplying. So that's going to leave me with 2x plus 6 equals -16. And then, of course, let's see, I will subtract 6, just like in the previous example. That'll leave me with 2x equals -22. Now be careful of your negatives here. A negative plus a negative, or a negative minus 6, you need to add those together because they're the same sign. Next, I'll divide by 2. And that'll leave me with x equals -11. Don't forget to put the word or in there. Now let's see, what does the graph of this look like? Here's 0, -11. Let's say 5 is about right here. So to graph this, I need to put a solid dot on 5 and a solid dot on -11. Okay, let's scroll on down to the next example. Okay, now I notice here that I've got a negative outside of the absolute value, so I need to isolate this expression first. Well, as always, remember, if there's no number there between that negative and the bars or the parentheses, then that's a -1. So to isolate this, I'll go ahead and divide by -1 first. And then that's going to give me the absolute value of 2x plus 6 equals +12. Now that's important because remember, absolute value can never have a negative answer. Let me say that again. Absolute value, when you have the absolute value bars here, this cannot equal a negative answer over here on the right. So now that I've got my absolute value isolated, I'll go ahead and write my two equations. And yes, this is necessary. Some of you are going to question this. Or the opposite of 2x plus 6 equals 12. Okay, don't forget there's a -1 here. All right, so let's go ahead and solve this one. And I think I'll move through this one a little quicker because of the stage of the game we're in. You guys should understand this a little better. So here I'm going to subtract 6. That's going to give me 2x equals 6. Next, I'll divide by 2. to finish isolating x, and x equals 3. Or, over here, I'm going to divide by -1 to get rid of that -1. Again, I could distribute here, but I'm choosing not to. I'm choosing to get rid of that negative first. So that's going to give me 2x plus 6 equals -12. Then I'll do the same steps as I did with the other side of this, the other side of the OR. That's going to give me 2x equals -18. I'm going to divide by 2. That's going to leave me with x equals -9. So again, if I'm asked to graph this, 0, we'll put our 3 right about here. So let's go ahead and put a solid dot on -9 and a solid dot on 3. We're asked to write this in set notation, -9, comma, 3. Okay? All right, let's move on to the next example before we run out of time here. All right, so here I see that I've got a +3 outside of the absolute value bars. So here I'm going to add 3 to both sides to isolate that absolute value expression. Now I've got the absolute value of 2x plus 6 equals 16. Oh, made a mistake. That should be a absolute value bar, not a parenthesis. Sometimes I get going too fast and write the wrong thing. Okay, now at this point I have nothing outside the absolute value bars. I've successfully isolated it. So now I'm going to write my two equations. The opposite of 2x plus 6 equals 16. Notice that the second one is always the opposite of, or negative, because remember, if the negative answer's in here, we also get a positive. And I'm going to leave you guys to solve those two because, yeah, we've already solved at least 2 with 2x plus 6 equals some number. All right, let's move on to our last example, and then I'm going to leave the your turns to you guys. So let's see what we get here on this one. So I'm going to add 9 first because remember, I'm working backwards through my order of operations when isolating something. Equals, let's see, 27 plus 9 is 36. All right, now I want to isolate this expression, so now I need to divide by -4. Okay, so that's going to leave me with the, because this cancels out, 3x minus 6 equals -9. Now I notice right here I've got an absolute value expression, isolated, just absolute value, equals a negative number. And that cannot happen. Therefore, this is a no solution. Okay, let me caution you again. Absolute value equals a negative number is a no solution. All right, let's take a look at this challenge problem. The diameter of a piece of metal rod is 2.5 inches with an allowable error of 0.05 inch. Write an absolute value equation and solve it. Okay, so if the perfect size is 2.5, then let's let W, actually let's let D equal the actual diameter, the actual measured diameter. Because obviously every piece of metal rod is not going to be a perfect 2.5 inches. So that would mean that the difference between the measure and the perfect size would have to be within 0.05. And of course you would set this up and solve it just like any other absolute value equation. Okay guys, I'm going to leave your turns to you. Here's your homework problems at the bottom. There's only 6 of them for you to do tonight. All right.